Guys, today we are going to talk about big data Hadoop and Hadoop ecosystem. My name is Anurag Idlavatkar and today I will take this particular topic. We'll try to do deep dive of this particular topic and understand like what is big data, how and what are the different sources of big data there, and how Hadoop helps to handle big data. Then what are the different components of Hadoop? So, what are, in other words, it will be what will be the Hadoop ecosystem. So, ecosystem will tell you what are the different components which are associated with Hadoop. You are part of purely be part of like Apache project, and you will be coming from other sources. So these are the different things. We are going to understand lot many other terminology as well, and these terminology will help you to understand big data, Hadoop ecosystem, everything in depth. We are going to talk about each and every topic uh, in a way that you will be that information will be useful for you for long run. Fine. So let's start with today's agenda. So agenda of the day is like okay, first of all I will introduce myself. So trainer introduction will is there. Then we are going to talk about big data, different sources of big data. So where this data is getting generated and what are the different sources are there, and then what are the solution which are available for big data, and what is Hadoop, and what is Hadoop ecosystem, its components and everything. And before concluding for the day, we are going to architect big data solutions using Hadoop. We are going to see 8 use cases for that and understand that how you can use Hadoop practically. Means these are the practical examples right there. Of course, they are not coding stuff. They are absolutely theoretical things. But yes, like when we talk about people who have a role of architect in their organization, those who teaches a big volume of people, they they give architect solution. Actually they don't give you uh, code by code solution for anything. So we will understand this thing uh, in depth. Okay. Now, right here, if you can see, it is about, it is my profile, it's my detail. My name is Anurag Arun Edlabadkar. I'm MSc Computer Science from Bhopal University. I did my post-graduation in year 2002. Currently, I'm working as Director Big Data Analytics, Nagpur. This is startup. We just started in January 2020. We, uh, we basically, uh, very precisely, I will say, like into data science and data science solutions and all those things. Prior to that, I was working in IT companies. I worked nearly 15 years, and I worked for Capgemini, Zensar, Blue Star Infotech. Technologies already you have seen. These are my contact details. So if anyone wants to contact me after this program or in future, in near future they want to contact me, then they can note it down my contact details. You can connect me on LinkedIn as well, and you can also comment in LinkedIn about all this. So let us start with big data. So like one thing which always come in our mind, like what is big data? So like the picture which comes in our mind is something which is very big. Okay, it can be a human being, it can be a very big fish, or a very big elephant, or a big fat hen, or something like that. So actually, we are trying to uh, correlate that with something which is very big. So more of the question is associated with volume, but big data says that no, we are not bothered only about volume. Big data says like there will be few parameters on the basis of which we will consider that okay, this particular set of data is considered to be a big data. Now how they are doing that particular thing, it's like what are the different things which are right there which are associated with your big data. Of course, very first is your volume. So what it is saying that like when we say it is big data, then few characteristics are associated with big data. I will say like the definition of big data says that if a data is associated with these three V's, then it is considered to be a big data. So first V is your volume, second V is your velocity, and third V is your variety. So let us understand what is variety. Okay, so basically data is divided into three, I will say three sections, three forms, or three classes. Okay, so first data, that is your structured data, and majorly we deal with structured data when we talk about any computer program or any solution or anything like that. Okay, so we consider a data more into a tabular format, like into row and column format, and then that such type of data is considered to be a structured data. Now, when I say structured data, it means my data will be in rows and column format. Each cell will give me some information. It stores some information in that particular cell, and then when I will go through row number so and so and column number so and so, then I will get the correct information from that particular section. So that is called as your structured data. Now, what are the examples of structured data? So first example of structured data is your Excel sheet. Your Excel sheet gives you rows data in your rows and column format. Okay, everyone is very used to of Excel sheet, so there is nothing. If you will close your eyes, a picture of Excel sheet will come in front of you. All the database, okay, it can be your ordinary DBMS, or it can be it's like it can be any ordinary relation, the database management system, or you have a relational database management system, and the third one, that is your object oriented relational database management system, that is ORDBMS. Okay, so all this database management system, in which you find companies like Oracle, IBM, then Excel, Access, Microsoft Access, and lot many others are there. You will find Google and a number of other ones, right? So these all are into structured data. Okay, and till I will say like till 2010, we were majorly dealing with only structured data. We were not talking about anything else. Okay. So whenever someone says that, okay, I need a solution for so and so thing, we ask them data, and that data is coming in Excel format, or if they are sending us into, or they are asking us to access their ERP system, CRM system, or any other system where everything is in tabular format. So that is your type number one, that is structured data. Now, when like researchers or these people who quite deeply involved in lot many research work, and so they understood this, like this particular structured data is only 20% of knowledge. So it means to say that if I really want to access knowledge, then I must go for the another 80% data as well. So 20% which is captured into structure format. So remaining data which is not been identified from long time, and it is considered to be it is not been considered, I will say it is not been considered, and then that is that need to be addressed now. So that is called as unstructured data. Now 80% of unstructured data, and my structured data is 20%. So I'm till a long time I'm missing 80% of the data to be processed and taken care. And the reason behind it is the 80% unstructured data is not for these RDBMS systems. It is very difficult to handle unstructured data. That's why we are not able to capture it and process it and take information from it. Now, they what they have done is like they in this particular category of data, they they find that like your videos, audio files, images, your XML, JSON files, and your PDF files, and thousands of such type of sources are there, which are part of your unstructured data. And here they have done one more segregation in unstructured data, that is unstructured data is comprised of two parts. One is unstructured data, and second is semi-structured data. So what they are saying right here is that unstructured data and semi-structured data both are totally 80% of your knowledge, and that is not been handled from long time, and that need to be handled. Okay, so they need something where this data should be taken care. Now let us understand structured. Sorry, we have already talked about structured, so we have to take care of unstructured and semi-structured. So semi-structured data is the data where that particular data comprise of structured and unstructured data both. So that particular data will will carry few structured data and few part of unstructured data inside it. So that's why it is called as semi-structured data. So like your email is comprised of one part that is considered like 2cc, BCC, subject line, and all other thing. That is tabular format. So that data goes in a table, and the remaining body attachments, smiley, emojis, and all other things that goes into the unstructured section of that email. So how your email is captured, so that particular thing is considered to be semi-structured data, and purely unstructured data is your images, your audio files, your video files, and all such type of things are considered to be. So we talked about variety of data, the type and nature of the data, and what are the things which are associated with that. And we also talked about that my RDBMS system is not capable, and it is not feasible for that to handle unstructured one. That's why for a long time we were not able to extract knowledge from our unstructured data. Second is your velocity. Velocity means in a speed in which data is getting generated. Okay, so let us take a very simple example, our day-to-day example. So I hope maximum people of you are using tools of Google like YouTube and Google albums, and lot many such type of things are there, which everyone Google search engine and other stuff right there. You people must be using Facebook, Twitter, WhatsApp, and other portals as well, and that to be very frequently, very frequently. So when any one of us is uploading a video, uploading a image, uploading or text, putting text on Twitter or Facebook or somewhere, so that generates data in the system. Okay, so it is said like that every 1 minute 300 hours of videos are uploaded on YouTube. 300 hours of videos are uploaded on YouTube. And in the same way, from past 20, 25 years, it is happening in the same way. So it will be like this is a very huge thing, okay, and that's why velocity word is associated with that. Okay, we are going to talk about 10 20 different examples of big data. We will take care of all these things, and the last one is the velocity, sorry, the volume. So yes, volume is part of that. Okay, there are few other things like which is now also associated with your big data. V is that is one is veracity, and it is the extended definition for big data, which refers to the data quality and value of data. Okay, the quality of capturing the data can be very greatly or affecting the accurate analysis. I perform any kind of analysis on data, and data which is captured, its quality, its that is play an important role. Of course, play an important role in that. There are few other terms which are, I will say, uh, associated with your big data, and which you will find in this particular presentation as well as in other places, uh, and we will deal with that things. Now, let us consider and let us understand data first. Okay, so we know that like very basic unit of data is 1 bit, and most elementary one. So 8 bits make 1 byte, then 1000 bytes makes 1 kilobyte, 1000 kilobytes makes 1 megabyte, 1000 megabytes makes 1 gigabytes, 1000 gigabytes make 1 terabyte, then petabyte, then hexabyte, then zettabyte, then yottabyte, then brontobyte, and GOP byte. These are the different units. Like when I purchased my first computer, I purchased my first computer in year 1996, and in that computer the RAM was 8 MB, and we were very happy that okay we have 8 MB of RAM, because at that time other systems we have seen of 2 MB and 4 MB of RAM, and I was super happy that I have 8 MB of RAM at that time. And what I remember is 512 MB of hard disk was there. So that was the scenario at that particular time. Then gradually, when this particular bomb was blast and digitalization was increased like anything after year 2000, the components of computer hardware, everything was and is damn cheap, and then it moved so quickly that right now, like we I'm using a 32 GB RAM in my laptop, and I'm using 3 terabytes of uh, uh, hard disk, and everything is like i7 10th generation processor and other things. So things have changed a lot from bits to GOP bytes. We are switching very frequently. In year 2002, scientists, researchers, and these people, those who are associated with computer and those who are associated with analysis and all, they said that like from the dawn till year 2000, whatever data is generated, whatever data is like, if the data is X, then every 2 years, so if it is X, then in 2002 this will be twice of X, and then it will be twice of 2X, then it will be twice of 2X of 2X, and so on. Thus, the speed of data in means the data which is getting generated, and now right here we are not talking about only unstructured data, or we are not talking about structured data, we are not only talking about semi-structured data, we are talking about all the three types of data in one go. So what we are saying that this particular, I will say, after digitalization, the in the way data is getting generated, so rapidly, and companies like Facebook, WhatsApp, and your Google and n number of such type of different they are generating data in petabytes per second, and that is the reason data is like I will say it is spreading like anything. Okay, and uh, it is something in upcoming days. It will be something uncontrollable volume. Okay, now when we talk about this particular it's like data getting generated, how to store this data, that was one challenge for lot many people. So they come up with one particular solution for that. Then second was how to extract knowledge from the data which we are capturing. So they need some technology which is helpful for that. Like we already talked about this very clearly, that earlier we were into one situation where we are able to only analyze structured data, and we also know that this structured data is only 20% of the overall data. So if I am able to only analyze 20% of data, then it is of no use, because still 80% of knowledge is not touched. So we have to consider something which is keeping complete 100% of data and analyzing it and giving me the solution. Okay, and once we process this particular data successfully, then I can say, okay, right, we have the correct data with us. Okay, what are the different, I will say, different sources are there where this data is getting generated? We talked about Google and we talked about one or two other stuff right there. Here we have a small list. I will say it is a very tiny list of such sources of data which is generating digital data every second. So first is your educational organizations, educational portals, educational such type of websites and other one. Okay, now these websites, like they every quarterly, every month, they generate results for students. They upload those results. They generate digital material. They upload that digital material on their website. Few of them are available globally, few are available only for their intranet, but still that data is available on cloud somewhere, and it is accessible for all. Now, giant one, that is Google, which is which is comprised of like if Google is a parent company, then I think 500 or 600 small companies are inside it, including your YouTube and a number of other ones, your Gmail, and each and every like for example, we talk about Gmail. So Gmail with respect to big data. So let us talk in that particular way, so you will understand more in depth about Gmail, and you will understand how it is contributing in big data. So Gmail, I think more than billion users must be there of Gmail, and if at one moment if 10% of people are accessing Gmail and writing mails and sending mails, and so 10% of that of 1 billion is again a very huge volume. Every second they are sending emails, they are accessing one, they are writing, commenting, replying, and so on. So velocity is right there. As I already told you, email is part of semi-structured data. So we are dealing with variety of data right there, and quality is also associated with that. Same example, another example of Google product, that is your YouTube. So on YouTube, you every second, I already told you, every 1 minute they are uploading 300 hours of videos. Means like globally, 300 hours of videos are uploaded on YouTube. Now these videos, people comment on it. They put some smiley or something like that. They like, dislike it, or some other stuff is there. Some people put their link in that and other things which are associated with that. So again, it is generating data. Okay, so every 1 minute, 300, if one video is of suppose 5 MB, so 300 MB into 5 MB, so 1500 MB of data per minute is uploaded. So this is a small example of 5 MB. It may be bigger one as well. Okay. Now government organization. So earlier it was only very, uh, I would say, developed countries were using 100% of computerization. Now it is landing up everywhere. So even underdeveloped countries are also uh, trying to 100% computerize their government offices and putting everything or converting every data into digital one. No paperwork is there. They are trying to do each and every job in computer without any paper. Another is healthcare sector. So in healthcare sector, they are converting each and every information which was like this, their research work, their all the things in information of your patient, right from information of your patient to I will say research on any particular disease or something, whatever is there, they are converting into digital format, and then it is globally connected and it is available. So healthcare sector is one of the important one. Then information technology, IT companies. So when we talk about IT companies, as this particular terminology is purely uh, associated with your big data and solutions and all these things. So whatever work is happening in IT companies, that is again purely generating a large volume of data or digital data, and which is going on your cloud and such type of places. And of course, data which is generated is in again in all the three formats. Wherever we were talking about, like in healthcare sector, government sector, or anywhere, data is generated in all the three formats. You will find documents, you will find log files, you will find structured data, and other one. Then you have insurance, you have international development. Let's talk about IoT. Let's talk about Internet of Things. So now uh, we have all the devices within our home and around us. They are purely IoT devices. IoT devices means like I give one command. I'm driving right now. I'm in car, and from my car, I'm on my mobile. I'm giving command to AC at my home that start AC and make the temperature 24 degree, and other such type of stuff is there. I don't open the door by lock and key. I just give a voice command and my door get open, and again it locks like that, and lot many things are there. So these all things are purely IoT stuff. You have driverless car, you have infinite such type of applications around you. Uh, Everything which is available on your mobile phone, which performs such type, any type of thing, means like you are controlling your AC, television, or something. Everything is generating set of data, and that is again a source of big data. Then media. So now there are millions of TV channels around us. Means globally, if we talk about, there are at least 1 million TV channels around there, local, then country-wise, then international, and so on. So that, and then other than that, if we talk about media, then in media you will find private channels like your Netflix and Amazon Prime and Z5 and another lot many such things. These are generating petabytes of data per second, and again it is going somewhere, and it is stored somewhere, and you are accessing that data. Another is retail sector, then satellite data, then stock market, and much more. Yes, much more means like I already told you, we have taken a very tiny list right here, and this tiny list uh, talks and give you an idea of what exactly, or what are the different sources of data, or different sources of big data. Okay, because everywhere, all the three important V's, that is your volume, velocity, and variety, are there. Okay, and that's why we consider all this as a important one. We These are the important questions, and luckily we have addressed all this in the beginning of that. First was your type of data. So we have three types of data: structured, unstructured, and semi-structured. Second is structured and structured, and yes, what are the traditional systems? So we talked about our RDBMS, how RDBMS was saving the data, role of RDBMS, and like incapability of RDBMS and these things, and why we need a new system. Because we need a new system because we don't have the capacity, or we the feasibility is not there, that we can go for this one, do everything with RDBMS. Okay, because RDBMS is just providing me solution of 20% of data. Okay, so what is what is the ultimate solution? Okay, so how to deal with big data now? So dealing with big data, I will say big data is a problem, and Hadoop is a solution of that. Big data is a problem, and Hadoop is solution of that. So let us understand what is this solution is. Like we are saying that big data is a problem, and Hadoop is a solution. So let us understand what is Hadoop, and then how it is helping us. Uh, Hadoop product, Hadoop was introduced by three different companies. One was Cloudera, Hutton, Huttonwork, and one is Mapar. Uh, Cloudera has 98% of stack. Then this remaining 2% is between uh, your Huttonwork and Mapper. And maximum companies like maximum of them are using Clara for all Hadoop solutions. Okay. Now, when we talk about Hadoop, Hadoop is associated with Apache. Apache Hadoop is a collection of open source software utilities that facilitates uses a network of many computers to solve problems involving massive amount of data and computation. So, in very first line of definition, we are talking about massive amount of data and its computation. It provides a software framework for distributed storage and processing of big data using the MapReduce programming module. Hadoop was originally designed for computer clustering built from commodity hardware, which is still a common use. It has since also found use on cluster of higher-end hardwares. All the modules of the Hadoop are designed with the fundamental assumption that hardware failure are common, occurring, and should be automatically handled by the framework. Most important thing right here is we are now capturing 100% of data. We are not doing something like our RDBMS that it is taking only 20% of data. What we are doing is we are taking 100% of data. Okay, we are taking 100% of data, so it means it is taking or it is consuming structured, unstructured, semi-structured data all, and we are doing means like computation and all those stuff we will talk down the line, of course, when we will go or we will land up into Hadoop ecosystem. We will see all those things quite in detail and understand this thing. The terms like here we are using, so it provides a software framework for distributed storage. So storage is not at one place, it is distributed storage. Okay, that is one thing. Processing of big data using MapReduce programming module. So there is one programming language, MapReduce, which is used for your big data. Okay, now data can be anything of any type, but my MapReduce is helping me to access that data and provide me the output. Okay, Hadoop was originally designed for computer clusters built from commodity hardware. We are going to understand what is commodity hardware. Okay, so like commodity hardware. Okay, so commodity hardware means a place where you will find infinite storage space. Okay, commodity hardware is again like infinite storage space and which is available on rent. Okay, a very high end system with infinite storage and available on low cost rent, that is considered to be commodity hardware. What we were doing earlier, like till like I will say 2010 or little bit behind 2 3 years back to that. Till that time, for every company, for every solution, and for every project, we used to first start with hardware. Okay, so like we are implementing ERP for ABC company, and now ABC company gave me all the details that what will be the their architecture and what will be everything is like, and we analyzed everything for that company, ABC company, and then very first thing we told them that okay, we will need XYZ servers, and their configuration will be so and so, and this one and that one. So these servers that will cost you 2.5 crores, and this one, that one. Then license cost, then implementation cost, and this and that. This is the list of all the projects which were done earlier. Okay. Then the time changed, and like this particular concept, like what is the problem with this concept of having in-house servers and all those things. Uh, these servers, or its maintenance, its upgradation, uh, everything means like there are a lot many things which are associated with that. That is overall very costly job. Whereas if you go for commodity hardware, you don't do any such type of headache. Okay, you don't do anything like you have to just simply tell them that I need so and so space, so and so volume of space, and its configuration will be so and so. So they will give you in a fraction of second that much space, that much RAM, that much processing speed, that much whatever you will ask, all everything will be available with you. What next? So next is like I don't do any kind of maintenance. I'm not bothered about backups. I am not bothered about anything. Everything is done at that particular end. We have to just pay piece of that, and which is very very less as compared to the previous one, and then we can enjoy the service. That is your commodity hardware. Now, like another terms which are right here, like risk of failure and all those things. We will talk about that. Don't worry about that. And we will see the architecture as well of Hadoop, and we will see lot many other important things in this. So this is very basic definition of Hadoop. Okay, what Hadoop is giving us, or what we are getting through Hadoop. Okay. For everyone right now, important thing is Hadoop is providing me a storage space. Okay, and this particular storage space is it is just not like your database management system that there should be one like you create one database, then everything should be in table format, and lot many things are there which were related to your RDBMS. Now what we are doing right here is we are taking all type of data, structured, unstructured, semi-structured data, and we are putting that all into Hadoop. And later we are performing operations on that. Okay, that is a different thing. Okay, overall different thing. We will see all those things. Don't worry about it. Now, uh, Apache Foundation, Apache Software Foundation. We need to talk about it because Apache is playing very important role. What the Apache Software Foundation is a decentralized open source community of developers. The software they produce is distributed under the terms of the Apache license, and it is free and open source. The Apache projects are characterized by a collaborative and non-census based development process and an open and pragmatic software license. Each project is managed by self-selected team of technical experts who are active contributor to the project. Uh, Now, in very easy language, understand this particular thing. Like they bring lot many companies, lot many solutions under one umbrella of Apache. What they have done is there are like different companies, different developers. They are developing lot many different solutions right there, and these different solutions, these developers and these companies are interested to keep into open source category. Open source category means like where your software is being used for commercial purpose, for personal purpose, for any other purpose, but it is absolutely free. Now, I will give you a simple example to understand this particular thing. Is there are two operating systems. One is Windows operating system and one is Ubuntu. So Windows operating system is associated with a license, associated with a license price, and uh, earlier it was yearly, but now it is for one system, one license policy. Uh, where else, in the case of Ubuntu operating system, it is purely free one. It doesn't come with any commercial thing or anything. And whatever applications are there with Ubuntu, you will find maximum them are free in cost. There is no commercials associated with that. Uh, you will find some challenges, yes, that few softwares are not supported with Windows or with Ubuntu, but yes, uh, like it is part of that. Like uh, if you go for a Mac machine and softwares which are available for Mac is not available with Windows and so on and so forth. Open source, open source community, they are providing everything free. They are providing everything free, and I don't have that figures right now in front of me, but it is nearly like 20-30 billion rupees. They means this open source community is saving by just distributing the softwares free of cost, and people are doing good development using this uh, free freewares and free softwares. Okay, so like when we talk about Hadoop, when we talk about things which are associated with Hadoop, everything, everything which is part of Hadoop system is free, 100% free. You can download Hadoop from Cloudera website, install on your machine, install on your server, wherever you want to do that. Follow the steps and everything. Now, when you download Hadoop, you will find all softwares of its ecosystem inside it. Very rare of them you need to install from the website and all those things. You don't need to do lot much work with respect to licensing and all those things. It is purely free thing. That you don't do anything right there. You have to just start using it, and that's it. That is the beauty of your Hadoop. Okay, and I will appreciate Apache for this, that they come up with this concept and they bring all these different companies at one particular place and help the system. Okay, now uh, okay, now what are the different components which are associated with your Hadoop ecosystem? Okay, so basically, uh, like it started somewhere near 2008. So very first version of Hadoop was Hadoop 1.0. Right now, we maximum people are using Hadoop 2. Hadoop 3 is introduced, but it is not in use, and still it is not clear about Hadoop 3. But we will talk about Hadoop 2 and we will see everything with respect to Hadoop 2. So, Hadoop distribution file system. So, Hadoop created a file system for capturing the files. Okay, so of course it is totally different from the file system like NTFS, FS, and another one, lot many other ones. So Windows has a file system, then Unix has a file system, then your Macintosh has a Mac. Uh, they have a different file system. Ubuntu has a different file. So all the different operating system, they are maintaining the files in different. So Hadoop introduced one different file system for itself to capture the files. And the reason behind it is they want to they want quality in processing the data. They need speed in that. They need not many things which are right there. Because Hadoop is a place where infinite data is going to store. It's like right now also a very extremely high volume of data is there, and in coming days it will be exponentially going to increase. Okay, it will be 10 times or 20 times every year, and something like that is going to happen. So what Hadoop has to do is it has to maintain the data in a way that if someone is accessing something or some query is there, then the result should come quickly in that case. Okay. Second is Yarn. So Yarn is a resource manager. It is called as yet another resource negotiator, Yarn. We talked about MapReduce. MapReduce is a programming language or programming stuff. Then we have Spark, then Scoop, Flume, and Kafka. These are ingestion tools. Ingestion tools are the tools which insert data in Hadoop system. So Flume, Scoop, Kafka, these are the three very important ingestion tools right here. Then we have programming stuff like Pick, Hive, Impala, where you can query your data you can patch your data, you create a database for specific requirement, or you can do parallel processing and lot many things with. In many places, we also need automation of processes. Okay, so in other technologies or in other places, we use the word workflow for that. So what we do is we give end-to-end solution, and this workflow carry that solution with it. Okay, so it starts with one point. It takes the data, it processes the data, it moves the data to one system, then to another system, and lot many things it perform within the cycle, and ultimately the resultant is there. So workflow objectives are taken care in Hadoop ecosystem by Uzi. Okay, then there is one, I will say, GUI. This GUI uh, provides you nearly 100% solution for the all available components of Hadoop ecosystem at one place. That is U, HUE. So U provides you a GUI, so you no need to go at every individual place, like no need to go to Scoop or go to Flume or go to Kafka or go to Pig or go to Hive or go to. So don't go there on command line and go to that black screen and perform the steps of your database and all those things. U is connected to all of the stuff, and you give you a interface to access all the components of your Hadoop ecosystem. Then Cassandra, MongoDB, and your HBase, they are a part of your NoSQL database. So again, you have database in Hadoop as well. These database, these database are typical database. They don't talk about relational data like relational database. They take care of the data, whatever kind of data is there. It is structured, unstructured, semi-structured, whatever it is. They are not worried about it. And then they process any kind of data they query, and they do all the different type of operation on it. So let's move ahead. Now, this is pictorial representation of a small, I will say, a small part of your Hadoop system, and it will help you to understand what are the different things are there. So on the very left hand side, you will see a different data source. So you will find like your DBMS, RDBMS, ORDBMS systems. You have your structured and unstructured data. You have IoT devices data, and different websites data is there. Then you have image files, Excel files are there. And so when I say different data sources, so it is it comprise of those 100% data which is getting generated every second. My my system is not worried at all about structured, unstructured, or semi-structured data. Everything which is getting generated, it is stored in system. Okay. So as I already told you that Scoop, Flume, and Kafka, these are the three ingestion tools which are inserting the data in the system. Scoop, Flume, and Kafka. We will talk about all this. Don't worry at all. We will see everything. This data goes to your second set of section where you will see HDFS, Yarn, MapReduce, and Spark. Okay, so there is one green block right there, and inside that you will find four different terminology: HDFS, your Yarn, then you have MapReduce and Spark. Okay, right now we are looking into the ecosystem of your Hadoop. So Scoop, Flume, and Kafka moves the data to HDFS. Okay, data directly goes to HDFS. Whatever data comes right there, it is structured, unstructured, semi-structured data is there. It directly goes to your HDFS. Then your Yarn, which was introduced in Hadoop 2. In Hadoop 1, Yarn was not there. Directly MapReduce was interacting with HDFS. So Yarn will allocate resources, allocate things. It will take care of lot many different things at that particular place, and then MapReduce will process the data, and then it will be available for you. There are three query tools right there. That is Pig, Hive, and Impala, which works on MapReduce, or that uses MapReduce for their data processing. Pig, Hive, and Impala, all the three are just like your query tools, like your Oracle or your SQL Server, and so on. So you write select star from table name and such type of queries. So exactly same stuff is happening at this level of Pig, Hive, and Impala. You have in the bottom you will have Windows, Linux, Ubuntu, AWS, and another platforms are there. So we are not going to talk about these platforms right now. We will look only the above stuff. And the last one is your Cassandra, MongoDB, HBase, and Redis. So these are your NoSQL database. So if you want to directly move the data to these places, then you can do that. Okay. Means if you don't want to save that stuff in HDFS and you want to save it right here, you can do that particular thing. Okay. And the last one, that is third-party data visualization tools. So there are lot many such type of tools right there which can access this data, and you can create visualization and create reports. You perform analysis, data analysis, and lot many things you can do with the help of these visualization tools. So there is Power BI, Tableau, and so on. Lot many other visualization tools are there. So things which you need to understand right here is at one place they have provided everything. Okay, section which is at right, and the section which is at left, both are not part of your Hadoop system, Hadoop ecosystem. Your Hadoop ecosystem is somewhere in between these two lines. somewhere in between these two dotted lines, that is your Hadoop ecosystem. And this Hadoop ecosystem, not about the platform, I'm talking about only above Uzi and Hue, everything which is there, it is absolutely free. Okay, we are not talking about operating systems in the bottom. We are talking only about these different small boxes which are associated with your Hadoop ecosystem is purely open source and purely free for all the users. Okay, so this is your Hadoop ecosystem. Now let us consider one problem. Okay, let us consider one problem. I am working on a project. I'm working on a project where I have to process a good amount of data, which is in terabytes, and my requirement is which is little bit complex. So I have to do lot much processing. So I need a good processing speed, and I need some good storage space as well. Okay, I will reduce it to gigabytes, not terabytes or petabytes. My requirement is in gigabytes, and I have to do this particular thing. So what I can do, approach that is followed is called as vertical scaling. So what we normally do at our home or in our organization or in companies, what we normally do is we call the hardware guy and we add RAM to our system. We, if possible, we add hard disk, new hard disk to our system, or bigger hard disk to it, or we use multiple hard disks at the same time. And if my motherboard supports, then I use a good new processor for the same. Now, when we are dealing with such type of things, what we are facing, that it is helpful to me to a certain extent. Okay, my vertical scaling helps me to a certain extent, and when that limit is crossed, then I'm helpless. I'm not able to process such type of programs, or I am not able to develop such type of program, or process such big data, or lot many challenges are there. So Hadoop come up with a solution for that, and that is your, as you, I hope you people remember this in our definition, it was there. That is your distribution system or distributed system. Okay, so Hadoop come up with horizontal scaling. So what they are doing now, they are not increasing RAM or processor, or they are not increasing your disk space or something like that. They are adding machines to one particular network. Okay, of course, it is handled from one place, and multiple machines will be added to it. But what you are finding right there is, you will find that, like, it is adding CPU, it is adding RAM, and it is adding hard disk space to process one particular program. So earlier I have 32 GB, that is the maximum RAM available in my laptop or in my server or somewhere. But now if I have total 10 machines, and all the 10 machines contains 8 GB of RAM. So now I have 80 GB of RAM with me for processing, which is more than sufficient for processing. Earlier I have 2 GB of hard disk. Now 2 into 10, it becomes 20 GB of hard disk space. Earlier I have i5 processor. Now I have 10 i5 processors. So my processing speed is increased 10 times. Now this horizontal scaling, it doesn't have any limit. Okay, horizontal scaling doesn't have any limit, and you can keep on adding any number of machines. And the best part of it is that it doesn't need high-end machines. Okay, it doesn't need server type of machines. It can be anything, your normal CPU, normal machines, something like that, and you can add to your distribution list. So if you have 10 machines and your requirement increase, then you can add another 10 machines to it, then again 10 machines and so on. Okay, so this is the beauty of HDFS, Hadoop Distributed File System. Yeah, we are going to understand how files are getting distributed. Everything we are going to understand. Don't worry about it. But very first thing is you should understand horizontal scaling. So what we are doing is the same problem which was very difficult to get solved in my vertical scaling, where I have already increased number of processors. I have increased RAM size. I have increased my hard disk space and so on. I have done lot many things in that, but I was not able to achieve my goal. So that is done with the help of horizontal scaling. And as I already told you that horizontal scaling doesn't have any limit. We don't have any what we say count right there that okay, only 10 machines can be added or 20 machines can be added. You can have 20, you can have 20,000, so 20,000 machines as well. The architecture support any number of machines. That is the beautiful part of your horizontal scaling. So whatever volume of data is coming to you, you are easily keeping all stuff at one place. So this is your uh, like horizontal scaling and how it works. Okay, so I hope it is clear to all of you. Now we are going to talk about few terminology which will be used uh, in the next section when we will understand files and all those things. So right here we have racks, and these racks, they are like they are part of your horizontal scaling. So all the machines are kept under a rack, and every single rack has independent power source, and it has one node with it which controls that particular rack. So if my rack contains 10 machines inside it, so all the 10 machines has a control above it, and that is again supervised by another this one. But one problem only right here is like if some power failure or some technical issue went there, then my rack will complete rack will fail. It is not only a single machine, the complete rack will impact it due to that. We will talk about that as well down the line. Don't worry. Next is your data approach. Okay, so let's skip right this for a moment, and let us understand. Uh, let us understand this particular thing in a better way than. So we have a data file. Okay, so uh, we have a file of suppose 200 MB. Okay, we have a data file, text file is there named as noname.txt, and I need to move this file to HDFS. Okay, so what I will do is I will move this file to HDFS, but HDFS will HDFS will break this file into two parts. That is, one will be 128 MB and second will be your 72 MB. Okay, and it will keep 128 MB at one place and 172 MB at one place. Okay, this is one approach which is followed in your HDFS. Another thing which is followed in HDFS is like let me show you in other way. I say Google and I search something. I say data, big data, and Hadoop. Okay, right here if you see search result shows 3 crore search in 0.62 seconds. Okay, now behind the scene there are for example, means it is just an example, if there are 10,000 servers, okay, and these different 10,000 server, they all, somewhere in each server there is one set of information with respect to big data Hadoop. Okay, there is one set of information about big data Hadoop in all the 10,000 servers. Okay, and each server is of, for example, it is of suppose 5 GB. Okay, we are not taking it very large right now, we are taking only 5 GB server. So if I calculate in that way, so 10,000 into 5 GB, so it is 50,000 GB of data, and in that 50,000 GB of data I'm searching this particular thing, that is big data Hadoop. Okay, now in previous day when we used to write a query, select star from or select employee ID from EMP, what used to happen is I was querying the data. I was querying the data in the database. So when I run the query, the data used to come to the query. Okay, and then we pull the exact information, and it buffers in the RAM, and there was I will say processing problem and space problem and all those things come into picture. Hadoop reversed this particular approach. Hadoop reversed this particular approach, and what they have done is now my query is not fetching the data. In fact, it is going in the other way. My query is going to the server and fetching the exact data from there. So now data is not coming to the query. Now query is going to the data. So right here, what image you saw right now, that is the how data get accessed in Hadoop system. So there were two approaches. Means the previous RDBMS approach was when data used to come to query, or I will say human approach. So food used to come to mouth, not mouth is going to food. So Hadoop took the second approach where mouth goes to food and eat the food. So it increased the speed of fetching, and that is the result you can see right here. So this is the result. 3 crore 3 crore links are fetched in 0.6 seconds. You will find something better. Data science. So if I fetch data science, so it is now is not 3 crores, now it is 323 crore in 0.63 seconds. It is even not 1 second of time is required to fetch 323 crore links. Link means this is one link, this is another per links. So if you will consider like that, then it fetched so much information so quickly, and the approach behind that is this one. We will see that we will break these things, and we will understand why it is so quick. And one sample of that I have already shown you. But first, understand this thing, that my previous approach means I am talking about RDBMS. So in case of RDBMS, when we write a SQL query, select star from EMP. So what used to happen is my data used to come to query, and now we have changed the approach in Hadoop. We change the approach and we make the approach to the Tiger approach, where my query is going to the data. So if I have total 10,000 servers, my 10,000 server data will not come to the query. My query will go to 10,000 servers, and at each server it will fetch the information and quickly go back and return to the output screen. You have seen this output right here. That's the reason I have opened Google for you, and practically I want to show the correct stuff in front of you. So 323 crore results, and fetch time is only 0.63 seconds. Less than 1 second time we have fetched so much results. It means 32 crore pages, 32 crore 30 lakh pages are fetched per page. 10 links are there in just 0.63 0.63 seconds. So we are understanding terms right now. So this is one term right here, which is uh, used for data retrieval or data accessing in the case of your Hadoop. So we follow tiger approach. We don't follow human approach right here. Now let us consider we have a file of 3840 MB, that is 3.48 GB. Okay, and we have 30 machines. So in these 30 machines, I want to divide this data. So in the case of HDFS or in the case of Hadoop, the Hadoop distribution file system doesn't keep complete data at one place. It doesn't keep complete data at one place. It divides the data first in the chunk of 128 MB each. Okay, so 3840 MB will be divided by 128 MB. So 3840 divided by 128. So we need 30 machines for that. Each machine will only carry 128 MB of data. So one single file of 3840 MB will be divided into the number of machines which are available. Minimum size should be 128 MB. Then it depends upon how many machines are required. Okay, so now what we are doing right here is it's like there may be more machines, something like that, but right now to simplify the an example, to make you understand and want to make it easy, I have taken one small example right here. And what we are doing right here is we are simply dividing the file into 128 MB, and we are putting 128 MB in each machine. Okay, so when some query will come, okay, when some query will come, like I will go back to the RDBMS system. Like in like I have a database of 3.84 GB. I have a database, or I have one particular set of data of 3.84 GB. I write a select query on it, and I fetch that 3.84 GB of data. Now, uh, like I'm a developer, so I know this particular thing very well, that it will take hours and hours for a single machine to fetch this data using a SQL select query, and then like it may hang your machine, or the tool you are using, it will hang that tool, because 3.84 GB data is very large for your system. for an individual machine or for patching that information from a server and showing to your client or anywhere else or using in your programs. First of all, if you are using some GUI for running the queries, it will hang that GUI. Second, if you are using some command line or something like that, it will keep on running for hours and hours, in fact, for a day, and there will be lot many challenges right there. And the approach which was followed in your RDBMS will be the human approach, where the data will come to your query. No, not query goes to your data. Now, the situation which is in front of you, we have one 3840 MB of data in front of us. What we have done is we distributed it 128 MB on each machine, and this 128 MB of data. Now, when I will write a query, so this blue box which you can see on the top, which is your name node or your master node or your primary node or whatever you want to say, it will take that query and it will push that query to all machines. And as that query is need to fetch only 128 MB of data, not the complete 3.84 GB of data, in no time it will fetch that 128 MB of data and it will go back to its place. So what is happening right now is my query land up to the data and it fetched the data and it went back, and so my processing speed is increased, my performance is improved, cost is decreased. Okay, because CPU usage is less, then my cost is less. I hope you are understanding it properly. So we have like this example right here. What we have done is we took a 200 MB of data right here. This 200 MB data is divided into two. My first machine will keep 128 MB of data and the second one will keep the remaining 72 MB of data. And when someone will fetch this no-name.txt, it will take 128 from one machine and another 72 MB from next set of machine. Let us have a so this is my new file. This new file is of 300 MB. Now what we are doing right here is that is your 128 MB plus 128 MB, that will be 256 256 plus 44. So 256 plus 44, that is 300 MB. Okay. So now in this particular case, my data will go to three machines. First machine will take 120 MB, the second machine will take 120 MB, and the third machine will keep 44 MB of data. And when you will patch it, your query will come to these three machines. Technically, query goes to all 10,000 machines, but wherever is the data is there, it will pick up the data from there and it will give you the data. Okay, and if I have something like so we have another text file of 500 MB. So what I will do is 120 MB plus 120 MB plus 120 MB 500 minus 128 minus 128 minus 128 116. So last one is 116 MB. So this 500 MB file will be divided into 128 MB, 128 MB, 128 MB, and the remaining 116 MB file will be moved to the fourth machine. So I hope now it is clear to all of you that what we are doing right here. Okay. So this is your distribution of data, and that is what is followed in your Hadoop system. So now, like example is same, so don't get into more into that. Now understand these things. Okay, so we already talked about name node. So name node is HDFS consists of only one name node, that is called as your master node, which is blue in color right here, and it is on the top of that. And the master node can track files, manage the file system, and has metadata of all the stored data within it. In particular, the name node consists the details of number of blocks, location of the data node, that the data stored in it, where the replication are stored in. The name node has direct contact with the client. So this particular screen is your client. Okay, when I query, when I fire this query, it goes to your name node, and name node move that query to your data node. Data node returns the data. It goes to your name node, and from name node it comes to your client. So picture should be clear to all of you. Okay, now right here we are talking about one file, and its replication is only one. Replication means number of copies of that file. So right now the copy of file is only one. We are not talking about more than that. These three files, data node 1, data node 2, and data node 3, actually it keeps the data, and your name node, as name node itself tells that it is a place where all names are kept. Name of your data node. Okay. So what is your data node? Data node stores data in as a block. So like we already talked about 128 MB block. This is also known as slave node, and it stores the actual data into HDFS, which is responsible for the client to read and write. These are slave domain. Every data node sends a heartbeat message to the name node every 3 seconds and convey that it is alive. Okay, so your name node always check the availability of your data node. Okay, your name node always check the health of your data node. In this way, when the name node does not receive a heartbeat from a data node for 2 minutes, it will take the data node dead and start processing the block which is replica of same. Okay, we will understand replication and all those things, don't worry, because we are going to talk about architecture in a good way. Now, what we are doing right here is we took a 600 MB file. We already we have seen 3 examples. One is 200 MB, one is 300 MB, one is 500 MB. So let us have an example of 600 MB file. 600 MB file will be divided into 128, 128, 128, 128, and 88. Okay, so we have node 1, node 2, node 3, node 4, and node 5. So these data node, it will keep this data, and name node will simply keep the track of it. It will keep all the statistics of your file. Now, I consider that the data node is in rack 1 and I want okay, due to some circumstances my that particular rack fails, okay, and there is no heartbeat coming from data node 1. So what will happen is name node will consider that, okay, the file part P1 and P4 is now not available, and luckily we are keeping replica of the data. We are keeping replica of the data. We are keeping 2 copies of data. So one is in light blue and one is in dark blue. So light blue data set is 1 and dark blue data set is second replica. So in any case, if some data node fails, I still have data available in another machine. Let us understand it more precisely. The same 600 MB file and my replication factor is 3. So what we are doing is we are keeping 3 set of 1 file. So 1 file and its 2 more copies are available with us. Okay. What is replication factor and why we need replication factor? Okay. So replication factor is required because we are using commodity hardware. So in case of commodity hardware, there is high probability of accidents or like crashing of data or something like that. Okay, although it is hypothetical that commodity hardware fails or something like that, but still we don't take risk. So what is right there? So in such type of scenario, when we are keeping our data in commodity hardware, what we do is we go by safer side and we don't take risk and we keep copies of our. So normally preferred one, I will say, is minimum 3 copies of any data. Okay, I will say minimum 3 copy, which is followed globally. Okay, like companies like Google, they keep 6 copy of data at 6 different locations globally. So it may be your Antarctica, Arctica, or somewhere in Africa, or something like. So their data centers must be some globally available, and they keep 6 copy of every file. Okay. So if my one data center, complete data center failed due to some natural calamity, due to any cause, due to any reason, if it is failing, then my second copy is ready, then third copy is ready, then fourth copy is ready, and we have total 6 copies of each data. So my email, uh, for each email I have 6 copies available. So we should not be worried about that. Now, when we talk about this, like okay, we have 3 copies of each. There are some rules how to keep these files. We should not keep all the files at one place. So for replication 1, replication 2, and replication 3, its first file should not be kept at one place, second file should not be kept. So they should be shuffled one, and no 2 copies, same copies should be on one place. Sorry. I mean to say that suppose suppose the same example, we will not complex it, let's make it easy. So this is the file pqr name.txt. This pqr name.txt, we have divided it into 4 parts. So P1 is part 1, P2 is part 2, P3 is part 3, and and P4 is part 4. So these are the 4 parts. Okay, we are using yeah. So this is 1, this is 2, this is 3, and this is 4. So if I'm keeping P1 right here of first replica, then I will not keep another P1 of remaining 2 replica on this machine. Okay, so what I will do is I will keep P2 of other replica, and then I will keep P3 of some third one. Okay, I will keep P2 of first replica. Then I will keep P3 of second one, and I will keep P4 of third one. Then I will keep P3 of first one, P4 of second one, and P1 of third one. And P4, P1, and P2. Now, in any worst case, if my one machine fails, one set of machine fails, my remaining data will be always safe in the form of replication. Okay, I hope it is clear to all of you, because this is the best way to explain it, the replication factor and other stuff. And as I told you, your name node keeps only name. Name nodes keep track of everything. Name node keeps the metadata of your data node. So this is the, I will say, pictorial representation to make it simple. And we are just talking about like keeping one file one place or something like that, like three files. Normally it doesn't happen. It moves to, like, if there are thousands of servers, then you may not find two copies or two different replicas on one place. It may be on different machines. So if we have 3 files of 15, so on the 15 machines you will find one block of data available right there. Okay. Here, uh, so your Hadoop system works on master slave architecture. Okay, master slave architecture, like you people, from long time we are using this word and everyone knows this thing. Master slave architecture means there is one master and there are multiple slaves under it, and these slaves are serving the master and obeying the things and following the orders and all those things. Apache Hdfs or Hadoop distribution fault line system is a block structured file system where each file is divided in a block and predetermined size. These blocks are stored across the cluster of one or several machines. Apache Hadoop architecture follow the master-slave architecture, where the cluster comprises of single name node, master node, and all the other nodes are data node, slave node. HDFS can be deployed on a broad spectrum of machine that support Java. So one can run several data node on a single machine, but practical but in the practical world, the data node are spread across the various machines. Okay, let me make it very simple. I am just reading the definition for you people. Uh, the last line, what it is saying is, uh, uh, you have master and slave on a single machine, no issues at all. You can have master and multiple slaves on a single machine. No problem at all. Like this laptop which I'm using right now, I have installation of Hadoop in that. Uh, Actually, time doesn't permit to show all those things, but just verbally, I will tell you that what are the things are there. So we have a one name node in that, and I have two uh, data node in this. The last line just telling that practically it is not suggestible. So that is true because it it is very heavy thing. Okay, your big data or your Hadoop and all these things, they are not for a single machine thing. Okay, that is this architecture is made for a big or I will say for multiple machine stuff, and it is specially designed keeping that particular thing in mind. Okay, so thousands and thousands of data nodes are there. You have a name node with that. There are some probabilities that if my name node fails, like if data node fails, I have backup with me, I have replica with me. What happen if I have if my name node fails? So for name node also, we always keep a replica of name node, and that is called as your secondary name node, which keeps all the parallel information of your what we say, whatever information is there in your name node. So the precautionary things are always kept in the mind, and accidental things and all those things are right there, which are taking care of all this stuff. Okay. Now, when I say master and slave, so my name node is my master, and remaining all are slaves. Okay, so whenever I patch anything, as I told you, and in the definition also it is said like that, that you fire a query on the client to Google interface, which you are looking right here as your client. You write a query right here. Let me change the query. I will say uh, name of this architecture. So what I am doing is I'm right here. Of course, it will get converted into select name node and data node architecture from so and so, and then it will go to your name node. Name node will distribute this query to 10,000 data nodes, and from those 10,000 data nodes, it will patch the information and it will give you the result of that. I hope it clear to all of you. Okay, so that is the role of your name node. And as I already told you, that there is always one parallel node, that is your secondary name node is always there. If in the worst case my name node fails, secondary name node takes the control of that. Okay, so this is your master slave architecture. We I tried to I've tried to take as much as possible stuff of your architecture, but guys, it is very means I'm telling you very seriously that big data Hadoop and Hadoop ecosystem is very like it's a very big topic. You can't complete it into 2 hours or 4 hours or 10 hours or something like that. If you want to deep dive in that, then you will find lot many things right there. but I tried my level best to explain you uh, about this architecture. Until this point, we covered what is big data, what is Hadoop, and very first topic of your Hadoop ecosystem, that is your HDFS. Okay, and I hope you people are understanding all this properly, and uh, we will we will understand other topics also well in depth, uh, as much as possible, as time permits, and then we will in the last section of this particular presentation and workshop is the test case one, where we practically see that how means we will take a use case. We'll take the use case, we will understand the use case, what are the things are there in this use case, and then we will we will implement the big data solution, big data Hadoop solution to that, and then you will understand the flow as well, that okay, it starts with so and so point, it moves to these applications which are part of Hadoop ecosystem, and ultimately we are getting the output of that. Okay, and these all this stuff which we are talking right now, uh, if you have any questions, you can write me on that, and I will answer your questions. You can write me email, or you can use it. So we will move to the next topic, that is your part of your Hadoop ecosystem, that is Yarn. And we will understand how Yarn works and what are the different stuff which are there associated with Yarn, its architecture, its functioning, and other things.